Hi, my name is Isabel Shen. We're doing our problem number 20. So the question says, a bag of cement of weight 325 newtons hangs in equilibrium from 3 wires as shown in the figure below. 2 of the wires make an angle theta 1, which is 60 degrees, and theta 2, which is 25 degrees with the horizontal. Assuming the system is in equilibrium, find the tension T1, T2, and T3 in the wires. So I started by redrawing the picture given. So you have 3 tensions and a mass. So this is T3, this is T2, and this is T1, and this is the mass with weight of 325 newtons. So from there, I went to draw my free body diagram. And if you think about it, the tension in rope 3, or like T3, is equal to the weight pulling down on this. So T3 equals 325 newtons. And because of that, you can disregard the weight pulling down in the y direction. So when you're drawing your free body diagram, you have tension 1 pulling this way, tension 2 pulling this way, and then tension 3 pulling it, or as your downward force. So you're also given the angles. So if these are your the triangles that the wires form, you're given that this is theta 1, which is 60, and this is theta 2, which is 25, and this is T1, and this is T2. So from this you can get that in the x direction you have T1 cosine 60, and in the y direction you have T1 sine 60. And then here you can get T2 sine 25 is in the y direction, and T2 cosine 25 is in the x direction. So from here, I'm going to write the sum of forces equation. So sum of forces in the y direction equals T1 sine 60 plus T2 sine 25 minus T3, which is equals mass times acceleration, but acceleration is 0 because it's not moving, so it's 0 there. And then the sum of forces in your x direction equals T1 cosine 60 plus T2 cosine 25 equals mass times acceleration, which also equals 0. So you know that T3 equals 325 newtons, so you can rearrange the sum of forces in the y to be T1 sine 60 plus T2 sine 25 equals 325 newtons. It's like just rearranging the equation. And then I took the sum of forces in the x direction. So sum of forces in the x equals T1 cosine 60 plus T2 cosine 25 equals 0. And I rearranged it so that the equation is solved for t. So T1 cosine 60 equals negative T2 cosine 25. Oh wait, no, sorry. This all the way through is minus, because if you define the top as plus and the side left and right is positive, so one's moving in the positive and one's moving in the negative. So this is going to be a minus here, so when you shift it over it's positive. My bad. So you have T1 equals T2 cosine 25 over cosine 60. And then you can plug that back in to your sum of forces in the y. So you end up with sum of forces in the y equals T2 times cosine 25 over cosine 60 times sine 60 plus T2 sine 25 equals 325 newtons. So then if you simplify that, you'll get sum of forces equals T2, which equals 325 newtons, over cosine 25 tangent 60 plus sine 25. And then if you plug that into your calculator, you get T2 equals 163.12 newtons. So right now you have T3 and T2, so you just need T1. So I plugged this back into the sum of forces in the x direction that we already solved for T1. So if T1 equals 163.12 newtons times cosine 25 over cosine 60, and that gives you T1 equals a final of 295.67 newtons. That's all for that question.